Thanks a lot. Good morning. Can you hear us, Paolo, from ISPRA?
Yes, thank you. I can hear you.
Hear me? Oh, okay, perfect. Excellent. Good morning, everyone. My name is Pierre Chastanet. I'm the head of unit of cloud and software in DG Connect at the European Commission. Many thanks for all of you who have joined us today for this Connect University session, and for the colleagues who are following us remotely via the web streaming of this session. Just a couple of words about Connect University. The Connect University is an initiative of the European Commission of DG Connect, which aims to inform the general public, policy makers about the latest digital trends, and to stimulate debate and exchange about policy development in the digital area, which are highly linked to relevant European policies. So we hope to have a lively debate today as part of this Connect University session. And I'm very pleased to see so many people that have come over today for the discussion on this topic. I know there are representatives from many DGs, so our DG Connect, I recognize quite a number of faces, but also from other DGs, DG Environment, DG Grow, DG Energy, I know are also represented today. Welcome as well to the colleagues who are joining us from Luxembourg and from ISPRA. We will have one of the panelists that is speaking from over there. So currently, DG Connect organizes a number of Connect University session, a series that is dedicated to digital for sustainability. We want to explore how digitization is going to influence a number of processes, is going to influence the European economy. How can digital technologies help having the European economy becoming greener, but also look at the ICT sector itself. So how can we make the ICT sector greener? So of course we want to continue having a lot of innovation in the digital sector, but we also want to see digital innovation contributing to the climate change mitigation objective. So today we're going to be discussing about a number of topics pertaining to sustainable data center and cloud computing. So why is this particular focus on data center and cloud computing? Well, there is a number of studies out there that show that the biggest percentage of energy consumption from the ICT sector is actually stemming from data center. On one end, we are stimulating the good development of the data economy. We're trying to encourage companies to undertake digital transformation, but that in turn generates a huge amount of new data that must be stored, processed, archived, and will stay online more or less forever. But that means that the energy consumption generated by all this data is going to keep increasing forever. So what can we do about this? What are the relevant policies that we can put in place in order to accompany the good development of the data economy while ensuring that this is going to be sustainable on an energy consumption, on a carbon emission point of view over time? So this fits very well with the key priorities of this new commission that has entered into office just this week, effective 1st of December. Among the priorities, the political priorities of President von der Leyen, you have sustainability, climate change, and you have digital. So what we're going to be talking today is really at the intersection of these two political priorities, so digital technologies and sustainability. So in relation to this DG Connect at large, together with other DGs, I mentioned DG Environment, DG Grow, DG Klima, DG Energy, we're exploring together the relevant policies that should be put in place to accompany digital transformation in a sustainable manner. So on one end, try to maximize the contribution of digital technologies to sustainability, and on the other end, trying to make the digital sector itself more green. So data centers, connectivity, devices are really the main elements that we want to look into for greening the ICT sector. And data storage and processing are, of course, the key priority for us to look into. So we have a number of distinguished panelists today that will bring their perspective on this particular topic. They are experts from the field, and they will be able to enlighten us from their own research, from their own business practice about what we can do about making data storage and processing more sustainable in Europe. So our first speaker is coming from Schneider Electric. Barbara Frei is Vice President Europe Operation for Schneider Electric. She has been working in this area for quite a few years, and she will be able to present us the perspective of an equipment provider that is essential for the energy management in data centers. So help me welcome Barbara Frei on stage for her presentation. Many thanks, Barbara. The floor is yours.
So, pleasure to be here today in Brussels. I don't come so often to the EU Parliament, but it's always a big learning experience for me. Not only then presenting what is important for us as a company, but also then learning from the people here in this ecosystem what is important for them to be effective. So we're talking about energy efficiency, specifically in the digital or in the data center space. And what I would like really to start with, what is important in our company. So climate issue and sustainable development has been really a key driving thing in Schneider Electric already since several years. So it also has become a transforming factor, a choice of a model that we chose 15 years ago. If you know a little bit Schneider Electric, you might know that we have a slogan, a mission, which is called Life is On. So we say energy should be available for everyone, everywhere in the world. Then life is on. It also means that we should do more with less, and the movement that has really led us to a more digital and enhanced, efficient world. So this has been driving us in that sense, even that it also had been a growing factor on our figures. So Schneider Electric about 15 years ago was a 9 billion euro company. Today we are a 26 billion euro company. And of course, part of this growth is also related to data centers. So we have about 140,000 people in the world, all over. We call ourselves multi-local, but in principle, with strong headquarters in Paris, in Boston, in Hong Kong, in China. So for us, the multi-local aspect is really important, that this gives us also the overlook of different aspects. So I would say there are three major transformations in the company. One was very much from electricity to electricity and digital. So what you can see is we have energy and automation. And energy and automation can be, you have a simple switch or you have a connected switch. And this is an area where we invested a lot of money, because only what is connected can be connected to a cloud, and then you can measure and then you can start to optimize. So this is now representing 45% of our revenues, where 15 years ago it was less than 10%. Then also, it's not only products we are selling. You just were mentioning we are an equipment supplier, but we supply more. We also supply services related to it. We also supply software solutions, which allows then also to make analytics. So you have an advisor you put on board of a system, and this allows you to optimize the building and how you operate it. And this also now makes up to 42% of our revenues, which was almost zero about 15 years ago. And then also, as I was mentioning before, we are multi-local. Whereas before it was mainly Europe and the US where we were strong, we also started to build up quite a big footprint then in our emerging markets. And today, 30% that we do is in Asia, and specifically, of course, China, which is a strong foothold. And for us, China is not only a big market, China, of course, is also a big learning turf. What is coming from China, how to really improve it. And when we look specifically in R&D and data centers, a lot is going on today in China on this area. So I said sustainability is a driver for us. And a big commitment that we made was with the 1.2 degree Celsius coalition. I still have a problem to pronounce it correctly. It's this coalition where more than 30 companies now have joined. We joined in October during the New York Climate Conference. And what we have then announced is that we have set our new and ambitious targets. So until 2025, we want to be carbon neutral. Before we said 2030, then we went down to 2025. We want to invest until 2025 10 billion in R&D. Just to be clear, it's not every year, but it's until 2025 that we want to invest 10 billion euros in R&D. And we also want to train people to be capable to work in this area, to be upskilled. And what is also an important thing is that we also invested in technologies like SF6-free. So also SF6-free is an area where, in principle, CO2 can be avoided and contribute to the efficiency. And then by 2030, we want to be 100% doing renewable energy sourcing. Today we are at 80%, so it's quite close. And then the biggest challenge is then 2050, net zero for all supply chain. So that means whoever is supplying to us and the whole ecosystem, we are at zero, which is quite a challenge. Also the 2030, when we look at our own company, 2025, it has a big impact on your company cars, in the buildings you live in, how you move your goods in between. So it's a lot of efforts to get there. But we are committed to it. So this is a slide that everybody shows when they make a presentation to really show the sense of urgency. That means we are now in 2019. What will happen if we don't do anything? So if there would be no climate policies, the temperature will go up another almost 4 degrees. However, when we really go to the 1.5 degree pathways, then we should really make it. And I think this is what the young people and everybody now is striving very much in Europe. I think I've never seen such an exciting time for energy efficiency and for climate policy. I remember when we were young, and this is more than 30 years ago, we were against the army, we were against nuclear, we were against things. But now we have really people going to the street on Friday and demonstrating for a better world and really telling the adults, please don't destroy more the world than you already have done. And I think such a strong movement I haven't seen in the last 30 years, like in the last 18 months. And I see this as a big, big opportunity. Why as a big opportunity? Because we have two trends. On one hand, we say, okay, we have an energy transition. Energy efficiency becomes a new gold. For years, energy efficiency has not been really a topic. Now it becomes really a topic. It's the energy that we don't use. And on the other side, we become more and more means and tools with digital. So we have 5G, we have data which we can use. We have much more possibilities at a lower cost than we had 5 or 10 years ago. And when I'm just looking at the market, so we are also very much in the building market. And smart building market today in Europe is about 7 billion. And it's said that in the next 10 years, it will grow to 25 billion. And this is all driven in principle by the possibility I want to have digital tools to reduce my energy efficiency and to make a better place to work for the people. So it's not only about save the world topic from my point of view, it's very much also about what can we drive in the economy more. And when you look, I think there are two areas we're looking usually. One is the building area, where we say it should be all electrical and all digital, so that we also use decentralized generation. A building becomes a kind of prosumer, so it's even generating energy. And on the other side is the industry with all electrical digital. However, when you really look at these two areas, the building space is clearly behind the industry base. In industry, digitization is much more usual. Digital twin is not an unknown word, whereas in the building area, it just started about 5 years ago that you do BIM, that you start to design already digital, and you have a digital twin which goes through the whole process, and in the end, you have a model which allows you to smoothly integrate into operations and to save energy. Huh? And it's of course more complex because in a building you have much more stakeholders being part of it. So we have these two areas where in principle we see the part for a more sustainable world. And how much is it now concretely? So I would say that the energy efficiency that you can really get powered by digital, and not only by putting new windows there or have a further insulation on your house, can be up to 20% on average, or it can be even up to 80%. So we say today, when you look at all buildings worldwide, you could take out 80% on energy savings, and that's huge. That's huge. And this is an area where the producing industry already has been working on, but we have to do this then even more in buildings and specifically then also in data centers. So the digitization helps the industry to reduce energy consumption and also gain productivity. And we have showcased this also on our own sites, like in Le Vaudreuil, or we have also buildings like with Deloitte, the Edge, where we present this. So the Edge building in Amsterdam is one which is producing 102% energy. So it's using less than it's producing. And this should in principle be the future. What you can see here is our platform that we have developed in the last 10, 15 years to support this digital journey. It's our EcoStruxure platform, where you can see we are serving different end markets. It's building, it's data center, industry, and infrastructure. And as I was mentioning before, each digitization needs connected products. Without measuring something, you cannot really optimize. It needs a control, of course, that helps within the building or within a factory to optimize. And then you have a cloud-based layer where you do then all the apps and analytics. And here, of course, it's very much dependent on how much data do you really have that you can do the analytics on. And we are starting to build this up and on and on. We have our own cloud solution where we have specific customers on and where we can drive this analytics. So here is one very concrete example from Finland. This is a logistics center in Finland. The customer came to us. They wanted to have a sustainable solution. And the task was clear. It should be 100% renewables with solar panels, a CO2 reduction goal of 40%, and energy efficiency 30% to the existing solution. And this has been done by really providing a solution. So it's not only about then the products you put in, the low voltage, the medium voltage. It's also about then the software you put into it, so that you can really then manage the demand and the supply of this side. And it has been quite a success. It has just been commissioned about half a year ago. And of course, we hope that this is a good reference to really continue the journey. We still see certain reluctance to really start to think about this. And usually, when you work together with the customer, it's not a more expensive solution. But of course, it needs from both sides, from customer side, from our side, a good collaboration to find then the right and innovative solution. As you can see, also energy storage here is a big thing in this whole setup. So, but what is the big topic really? Huh? I'm usually also asked in interviews by journalists, hey, is this not contradictory? On one hand, we need to save the planet, less CO2, and then you tell us you do this to digitization, but we all know these data centers are really burning energy. And you know, like in cities like Frankfurt, data centers are the power consumer #1. And just Amsterdam was talking about the moratorium because they don't have enough power to really feed all those data centers. So the consumption of energy and electricity of digital origin, of course, will grow. Even, of course, there are big uncertainties about the scale. But some study estimate that the digital energy consumption could be multiplied by 10 by 2030 if no action is taken, reaching 20 to 50% of global electricity consumption. And now, by taking proactive actions, this increase would limit around 15% of the electricity consumption in 2035, or compared to the current situation. This comes largely from the rise in IP traffic in telco networks. So instead of really having an analog line, we have now IP, which is of course going to more digital. This includes not only hyperscale data center, but also distributed IT that is driven to the edge of the network. So instead of having a big data center, which is the approach today, more and more companies go to edge computing. That means if you're a big retailer, all the data which is usually done is computed in edge computing in the different outlets. And only when it is required, mainly on a monthly base or weekly base or daily base, the data is uploaded to the big cloud. And this kind of solution is coming more and more because it's faster, it's more efficient. We at Schneider Electric are committed to maximize efficiency in data centers, big and small, through innovation and collaboration with our customers. And this is really important. The data center industry has made tremendous progress in the past decades. So if you now compare the power usage efficiency in 2006, it was about 1.84. So this is the measurement in the data center area, how you do this. From 10 years until now, we have increased this efficiency to 80% in data centers. So today, we have a power usage efficiency of 1.17. And then the next wave of digital transformation is driving IT to the edge of the network, as I was mentioning before. We must ensure that data centers at the edge are as efficient as the hyperscale data centers. The challenge is with the smaller micro data centers when they are deployed at scale. You have to imagine if you were to deploy 10,000 edge data centers, which is very likely, you would create at 10 kilowatt each, that's 100 megawatt of energy. And 100 megawatt, that's a small, I would say, small power plant, gas power plant. So it's quite the consumption. So if the POE is only 1.1, it would, of course, much more be efficient. It would cost less. And of course, 600 kilotons of CO2 would be then even additionally saved. So if you can bring this POE continuously down, you really have a footprint, CO2 footprint impact. So the data center of the future will have more interaction with the grid and renewables, greater variability of IT, a mix of complex cooling architecture, and more sites to manage in a hybrid environment. And this again is crying for software. So the more decentralized you are, the more you need to manage load. And the more software is required and the more you need data to process. So beyond data center, we of course need to look also at the broader ecosystem and start examining the performance in a broader way. So lowering the carbon intensity of devices, that's the footprint from each device. And this is the new, let's say, industry. Already 30 years ago, we were looking at the gray energy, but it has never really gained so much importance like now. And then also leaving the area of big data and entering the area of smart data with artificial intelligence. But this also needs quite a kind of openness between companies and countries to share data, which is today not very much given. Here is another customer example. It's from Interaction in France. Interaction is one of the biggest data center supplier, colo supplier in Europe. They just recently announced that they will come together with DRL. So then Interaction will become the European leg of them. And here in this data center in Marseille, we were able to save 24% energy efficiency, and 90% of what this data center is using is renewable energy. So this was also one of the borders here. And they are really in a pace. So this market is really growing at a pace that you don't see in many areas. So when we were talking about 10 megawatt data centers 2 years ago, now we talk 30, and they are coming in 6 month cycle, not just in every year one. So it's really a big market and a big consumption which we have ahead of us. So, to conclude, look, how could the EU ensure a stronger convergence between sustainability and digital? I think for us it is important that an ambitious decarbonization framework for buildings, industry, data center and energy network is done. So tapping really into the building's potential by giving, for instance, a CO2 reduction target for tertiary building. And here we are looking in principle at commercial buildings, education schools, and these kind of things. And then, of course, an ambitious implementation of the clean energy package in Europe. Then electrification of heating, especially in industry and buildings through technology push. Also, a data center is a heater. So district heating can be connected to data center. And then supporting the shift towards more sustainable distribution grid. And this is specifically meant to the SF6 free aspect. Then also better promote data center efficiency and decarbonization, and better deployment of the code of conduct for data centers, and promote the power usage effectiveness, the PUE targets, based on size, age of a data center, to better address also the small scale and existing data center. So there are many aspects here, but overall, again, I think the time was never so good to change something, and the time was never so strong in that sense that we have all the means to do it. So we have the tools, we have the digital means. 5G is on the horizon and will allow us to become even more clear with how we can collect data. So it's a good opportunity, and specifically data center need a big focus, and I think that's good why it's also this conference, because they are really the new energy drivers in Europe. And as I was mentioning before, that's already happening in big cities like Frankfurt or Amsterdam. So to have a focus on this, because again, what I don't want, and what happens now is that there are moratoriums on data centers. And one of our, let's say, economical progress in Europe is very much also dependent how can we pace up on this, on these aspects. Okay, thanks a lot.
We're going to take a few questions from the audience before we move to the next speaker.
Oh.
Are there any questions?
Speak from here.
Yeah.
Okay. So I've seen in one of your slides for the Lidl case,
Yeah.
you mentioned 30% efficiency increase. Can you say more of which technology solutions you implemented to improve efficiency? Thank you.
It's very much, of course, how you manage the whole system here. It's what kind of heating, cooling you take into the place. When do you heat? When do you cool? So here, in principle, when you look at where is the biggest energy consumption in such a building, it's heating and cooling. And through having a building management system and a power management system, this software helps you to reduce continuously then the consumption. There is, of course, also a learning curve, but usually after 1 or 2 years, you are at the targeted level. But again, a building, it's not very complex. It's heating, it's cooling, it's lighting. So, and this is the area where you put in principle the biggest efforts to get efficiency. Is it clear, or?
I was just expecting some breakthrough solution.
No, it is not. You know, that's the point. Whatever we talk today is never ever has been rocket science. But of course, 30 years ago, if I would have gone to such a building, it would have been a pilot and it would have cost 20 times more. 20 times more to create something like this.
Another question here.
Thank you very much for your presentation. Quick question on the skills. So you mentioned that you also wanted to commit to upskilled people working for you. So what exactly are the skills that they are missing? Because we speak a lot about skills, but could you give some more detail on that, please?
It's very much about the skills. There are two folds. One is the skills to be able to work in such an environment. So the technicians, the engineers who really understand what means energy efficiency. That's one area. The other very important area, and where we are also sometimes desperate to find people, is data analytics. So as I was saying, now we have connected products. These connected products are creating data. And then you need, in principle, people who are capable to analyze and make a conclusion out of this data. And what we put really an emphasis on is that we get more data analytics people on board. And if you would go to LinkedIn today, you would see a big number of job search for data analytics. And I think this is the area where we really can upskill people. It's difficult to say. 5 years ago, we didn't hire any of them. And now, I know it from Germany very well, we were looking at 5 in the last 3 months. So specifically also when you talk about pricing, when you talk about, there are many areas where this plays now a big role. Is it 10%? It's difficult for me to say. It could be that in 10 years, 30% of the employees we have are in this area. It's a bit difficult to predict.
Last question here.
Thank you. We're going to hear more about the EU Code of Conduct on data center, but you mentioned in your last slide the better deployment of the EU Code of Conduct. Do you have some concrete examples on how you see that?
I think it's important, of course, that those people who are building data center, that they really follow it. And it's not only the big colors, it's not only the Facebooks, the Googles, and the Econics and so on. There are more and more companies who have all still their own data center. So, and these are also, of course, big energy, let's say, eater. And specifically the edge is very much not big hyperscale. Huh? So it can be the Rewe in Germany, the Lidl in Germany. So, and all these companies also should be very much aware of this code of conduct. So for me, it's really also make it known outside of the industry. Because it's not only those who are using it, it's also the others. Oh, maybe you want to add something, huh?
We're going to have to move on.
Just a figure we have is from our own number, it's about 20% of existing data center which are using the code of conduct. And I think one of the main issues we see is actually a simple marketing promotion of this tool, right, across Europe. And I think here we be very keen to can work with the Commission to see how actually the private sector could also play a role in further deployment of this tool.
Okay. Many thanks for your answer to the question of the audience. I think the last point that you raised is a pretty good transition to the next speaker. You mentioned the challenge of the edge and the effect that this may have, this transition to much higher distributed computing towards computing that is closer to the user. But how is that going to balance out on an environmental point of view? So this is a trend that the Commission has seen. We saw this problem emerging, and that's why we have launched a study in this area at the beginning of the year to try to study the effect that more distributed form of computing would have on the environment, and how to actually balance out. So is it better to have things hyper-centralized but then pay an environmental cost in the network, or is it better to have things hyper-distributed and then leave very little at the center? So
may we ask a question from Luxembourg?
Not maybe for the next session, please. If you, I'm sorry we didn't. If you don't mind to park your question for until the next session, please. Our apologies. I couldn't see you were here. So let me welcome Bertil Heerink. He's the head of the European Affairs at the International Institution at the Federal Environmental Agency of Austria. You're not an Austrian national, but nevertheless working for the Austrian Environmental Agency, and you will present us how the study is looking at this aspect of cloud and edge computing and the environmental effect. Bertil, many thanks for.
Thank you, Pierre, and good morning, ladies and gentlemen. I'm indeed not Austrian, although I'm living in Brussels and Vienna, which is not a punishment, I must say. I'm Dutch. Let me first, indeed, Pierre, you referred to that very particular study which is currently running. I was asked to give a talk about digitization avenues for climate change abatement. And I do this where the study which we're currently running is a major part of, but it's not the only thing we do. And I think it's good that we just take you quickly through what we have done and how this study particularly fits into the thinking of digital in the broader agenda of climate change abatement. Which arrow am I supposed to? Oh, wow. So, okay. Let me first explain a little bit who we are, Environment Agency Austria. Then I am going through the various areas of research. First, the study which we've done in 2017 on green public procurement and how that can contribute to the EC Circular Economy Action Plan. That is a logical starting point because greening public procurement is also an element in the study which we currently use about energy efficient computer technologies, and the broader topic of what are we currently addressing in Austria on the broader topic of the policy options of digitalization as an enabler of climate change policies. So there is a consistency. Who are we? We are, as we always would like to say, the most important environment expert institutions in Austria and one of the leading consultants in environment and climate change, energy efficiency and digitalization to the European Commission, but also to international institutions like the UN, World Bank, EBRD, EIB, etc. We have experts in various fields and we have our certain values, obviously, when it comes to independence of advice, which is not only an important element to the key owner of the agency, which is Austria, the state of Austria, but also to all the institutions and international organizations which we advise. We have been founded in 1985, since 1999 a private company, but exclusively owned by the state of Austria. We have more than 500 people working in Vienna with a certain turnover and a very international portfolio. You see here, we work in 60 countries across the world and are partners in many different energy and environment and climate change related networks. A string of disciplines, I will not take you through them. It looks like a chemical reaction, and in a way it is also a chemical reaction because most of the things we have to do is, of course, multidisciplinary, and therefore we can draw from that. And all the themes, and also this one, which we discuss, is by its very nature multidisciplinary. So we pick the people who are necessary from our own networks. The areas of research. Where are we on digitalization, on public procurement, on energy use, and on this particular agenda on climate change abatement? There are here 3 studies mentioned. One has been carried out, as I said, in 2017. One is currently carried out for DG Connect and is close to its finalization, and a major one on the perspectives for the environment and society, where we focus on the various areas on how digitization can function as an enabler of climate change abatement policies. And I would like to bring this string of 3 in order to make the right connections between the various. So the study on green public procurement, let me talk to that first. It was carried out in 2017, also at request of the European Commission of DG Environment, how we could use or especially improve the systems of green public procurement across Europe, and how make that connect to the circular economy strategies and action plans which are currently unfolded and on the tables of many. There's a big study. The study is accessible. The study is accessible to the European Commission, obviously, as the one who asked for it. We argued in favor of more clear criteria on what public procurement, greening public procurement should be, and how that should be linked to the wiser use and in particular, of course, reuse of resources. There are many criteria currently mushrooming across Europe, and we strongly feel that there's a need to have a critical look at how that works in practice and how it could be improved. I will not mention details here, that's not the topic, but it was already the starting point. Please be practical and also streamline a lot of what is currently, I always say, mushrooming. Develop tools to support public procurement for innovative solutions linked to circular economy. I come back to that later in the presentation of the current study, where we have more particularly formulated some recommendations which I will touch on later on. Develop criteria of green public procurement linked to circular economy. How should that precisely be linked? Because they have been developing more or less separately from each other. So make that connection, exactly explain and formulate what it would mean for waste, for resources, reuse of materials, what it would mean for energy, what kind of thresholds you should focus on. So a very complete and elaborated agenda. Important also, strengthen the eco-design regulations as a legislative measure. Have a look at them and focus on green public procurement, and in order to make that stronger, and develop new standards for testing procedures, in particular the lifetime of products and materials and the use of materials and products. The transition to a circular economy, of course, requires a systematic approach, and it's also there is a sense of urgency. There is the need to accelerate the system. Things are too diffused and things are too slow. That is what you clearly see in terms of green public procurement. Please bear that in mind when I come back later on in the presentation on the study on energy and computing technologies. So, the study which we are currently finalizing and for which we have tomorrow a closing workshop with stakeholders, services of the Commission, academia, business world, business community, on what could be done. What is the issue here? The study is focusing on technologies and policies for an eco-friendly cloud market. So here we are really also in the same ballgame as what Barbara just has started to talk about. If you look at what we expect is the energy consumption from in this particular area of data centers, we expect an enormous growth, nearly a doubling of energy in Europe from 2010 to 2025, and the fastest growth happens in cloud computing data centers and edge data centers. So I was listening with particular interest to what Barbara said, that she, for her company, envisages energy efficiency gains of around 80%, and that is a wonderful news, but it's not the general picture. The general picture is completely a different one, and that requires that it shows a doubling in 15 years. You just can think practically. If a famous person in the world puts on his blog something which the whole youth wants to see, for example, football stars who put on their blogs what they just have been buying, or what kind of car, or what kind of things they find interesting, or which kind of disco they go to. The energy use of that is nearly equal as the annual energy use of an average African country. That is what we are talking about. That is an enormous, if you have that comparison, you see that there is a problem. And that is the scope of magnitude of the issue we address here. The current status, cloud computing brings new opportunities to optimize operation and utilization of physical ICT devices. It is possible, but you have to do it. Technically, also I echo what Barbara just said, there are many opportunities, but you have to use them. And the question is then, how can you trigger best that they are effectively used? I said already something about the energy consumption of data. And also there, I echo what Barbara just said. The data center infrastructure for cooling and interruptible power supply has become relatively more efficient. It's only a very small part of the whole cake. So what have we been asked to look into more particularly? To analyze and evaluate the current and future energy efficiency of cloud models. The study will be published very soon, so wait a little bit still. There are obviously a lot of details in it. Identify relevant technological developments. What is here actually? What is dictating this whole show? What is behind it? And of course, in particular, with a certain sense of urgency, suggest potentials for reducing energy consumption and identify and define appropriate policy options, including greening public procurement as one of the biggest markets in this area. So therefore I started with the 2070 study. There is a link to it. We identified key technological areas where we can improve. We drafted proposals for action for the future. We identified current status of inclusion of GPP criteria and how that could unfold in national action plans and other national initiatives. Identify best practices for sustainable and energy efficient cloud services, and as a final obvious wrapping up the whole thing, providing recommendations for policymakers and practitioners, sorry, difficult word for me, at European and national level in how to move forward. Tomorrow there is a validation workshop here in town, and it happens to be at the same day as when the State of the Environment report of the European Environment Agency will be published just across the street. So that is a beautiful synergy of what's happening on the Green Deal related issues in the European Commission and its agencies. The key findings, new key performance indicators for better comparability. You have to be able to compare what's happening. There is a need for higher transparency. I will come back to that if you wish a little bit later. There needs to be a better development and use of who does what in this field. Orchestration, beautiful word. Research on ICT trends and their impact, especially also on 5G, one of the biggest buzzwords and one of the biggest scopes of action. Edge computing, and analysis and evaluation of technology areas and specific innovations, plus various other recommendations. We have formulated 21 recommendations, which are on the table tomorrow with all these various stakeholders. As I said, that's tomorrow. And there is the address if you still have not registered and you would like to come over. The next area, perspectives for the environment and society, a larger study which we currently are doing for the Austrian government, but which in its nature is so broad and so big that it certainly cannot be restricted to the Austrian situation. It is, by its very nature, global. We have issued in 2018 a general overview, which we do every 2 or 3 years, I think, the perspectives for the environment and society. With this time the focus was on resources. That is the starting point, the thinking point of how we deal with energy as resource, how we deal with circular economy as a resource-related initiative. And we have identified that indeed digitization will be one of the major tools and vehicles, which is not only, as we have now done in the study, an issue which needs to be solved, but also an enabler, if we do it right. And that is what brings us to the study where we currently focus on blockchain, big data, the internet, and artificial intelligence. That study is currently under preparation. I have tried to get an answer when it is ready. The answer was so vague that I don't dare to quote it here, but it's somewhere in the coming year. Because what's happening is that this topic is so broad and technological developments are going so quick that for experts it's difficult to say, and now we stop, now we take it for granted as it is. This is the picture, and this is what we're going to publish. But of course this has to be done at a certain point. But you can therefore expect from us a study on these topics which involves where we stand, where are the recommendations, where are the challenges in all these topics. And I personally expect a lot about the artificial intelligence side and on blockchain. So that is the wider picture which we currently are doing. I could imagine that you would like to hear, and I do that as a sort of wrap-up, if that's okay for you, for discussion, looking at the clock. What are the type of recommendations which we will put on the table tomorrow for action? And there are various chapters. There is a chapter on awareness raising, information, that people know what's going on. There is one on transparency. There is a chapter on guidelines, on labels, on standards, on incentives, and also legislation, and also in particular to GPP. 21 in total. In awareness, the first chapter, we think in particular on information campaigns on the impact of cloud computing on energy demand. The picture I showed you from 2010 to 2025, if you show that currently in Madrid, I think it will be looked at very critically and will trigger an enormous discussion on what's currently going on, because that is just the opposite direction as we are supposed to go. Information, therefore. Also, what can be done in energy-efficient cloud computing for providers and companies and universities and the decision-making. So what could you do? What is the agenda where you could focus on? Transparency initiatives, ideas which are on the table is a cloud footprint or a virtual smart meter, will be discussed tomorrow. A digital environment repository, so also a data about what's going on. Guidelines on energy efficient cloud computing, code of conduct for energy efficient cloud computing will be discussed. Labels for cloud computing for low and high thresholds. A label EcoCloud as a service provider. Standards, cooperation on the development of standards. How could that be worked best through across the various stakeholders and actors? Incentives. What kind of incentives? I cannot discuss all these discussions in details right now here because that's just what we need to do, obviously tomorrow in the right setting, but that is the agenda. Legislation, where we think about strengthening the eco-design directive and establish minimum criteria for energy efficiency of newly built data centers in EU legislation. GPP-related measures include GPP criteria for green data centers, promote knowledge sharing among GPP groups, and probably think, and also for national criteria and for national plans, and perhaps more boldly, shift away from green public procurement, but focus on public procurement for innovation, which is a broader concept, which may be necessary. So there is a whole lot of things to discuss tomorrow. We'll see what happens. I hope there will be white smoke coming out of that building in the Boulevard Charlemagne, I assume also that will be the case. Perhaps not always easy, but we have been asked to, and therefore I started with the State of the Environment report, we have been asked to provide material in this manner to enable the Commission to include elements of it in the first 100 days agenda, because there is that sense of urgency. So that is why we find speed, but also the quality of validation very important tomorrow. That is what I would like to bring to you. That's where we stand in the broader scope, but also in the particular progress of this study. Thank you.
Stay with us for a few minutes.
Yeah, of course.
We're going to take a few mics here. Let's start maybe with a colleague from Luxembourg. My apologies, Paolo. You were not appearing on the screen, and you are now since you have taken the mic. So why don't we start with you in Luxembourg to hear the questions or remark you would like to make.
I'm sorry, our colleague from Luxembourg had to step out, so I don't know. We don't know his question.
Any other question from the Luxembourg side as you're on the screen?
As you could say, it was a good question. Next question.
Not at the moment.
From ISPRA, maybe?
Thank you. No question from my side.
Okay, so let's get back from the audience here in Brussels. Juan, please.
Thank you for your presentation. This question is maybe for both speakers. You referred to KPIs. The previous speaker referred to targets and PUE as, would that be the main metric that you would consider target setting? Okay.
Yeah, I agree with that. I mean, if you look at the whole discussion which we just had in Europe on the clean energy package and the importance of targets and how that was, in the end, had its place in legislation and the whole strengthening of it. Target setting is important in order to make sure that the right investments are made. Because it requires investments, and it requires also, it enables you also to know where you are supposed to go and measure whether you are on track or not, and if not, what needs to happen if the target cannot be reached. It can be because of the problem of the target, it can also be something else. So it's just a matter of knowing where you are and also to enable the stability which is needed to invest.
Thank you for that. And as a follow-up question, again to the previous speaker, you referred to this 1.5 Celsius coalition that want to be carbon neutral by 2025.
Sorry, no.
So the aim is for the for 1.5 Celsius coalition. The aim is to be carbon neutral by 2025. 2025. And that's a solid, that's a reasonable...
Absolutely, we are working on it. You know, each unit in our company...
Oh, sorry.
Each unit in our company, be it sales, be it factory, be it engineering, R&D, gets clear targets to reduce that. And we do this and we measure it quarterly. So I'm reviewing with my unit in Europe, how do we develop? And usually the factories are much more advanced than the sales offices. And this is exactly where I see a bit the challenge. Usually you are in rented buildings, usually you have cars. So how you transform also your car policy is a big thing here. So I think we are on track.
Thanks. We're going to take one more.
Just add something to what you just said.
As I'm walking the room to take the other question.
2025, with that objective in mind. And when I then just show you the picture of what we expect in this particular area, nearly doubling from 2010 to 2025, It shows not only the need to go that way, but also the need to be quite ambitious in setting the right path of measures, because otherwise you will have that sort of doubling trend towards 25, which is just the opposite direction.
Okay, thanks a lot. We have one question here.
Hey, good morning. I work in DG Environment in industrial emissions. And I have a question related also to your experience with the Austrian regulator. To us, environmental protection is more than CO2. And you have presented today, and also your the previous speaker, the trend of an increased activity and size in data centers. And the question whether you are aware of other pollutants that may arise from these activities. So we mean pollution to air, to water, to land, different than CO2. And if you are aware whether they are regulated today in one way or the other.
Let me first check whether I understand your question. You said, do you expect other pollutants coming from this particular development in this particular area of computing technology?
Of data centers, yes. Of data centers.
Not really. This is really about energy use, and this is really about CO2 emissions. And that's also what we measured. There are a lot of other problems, and not only in Austria, with other pollutants, which the zero pollution strategy we need to tackle in various ways. But in this particular area, this is really about energy use and CO2.
Okay, very good. We're going to take the last question here, and then we're going to move to the next speaker.
Thank you. So I saw that you mentioned in your presentation about different cooling methods. We also heard the previous speaker on the way forward mentioning also district heating solutions from data centers. Now there are several colleagues also concerned about noise emissions of data centers. Have you done any work on that? Or if you change the cooling method, does it also affect noise emissions? Because obviously, in order to have efficient district heating, you would need to place data centers in proximity of houses and inhabited areas.
Noise was not in the scope of this study. This was really energy use. But of course, the more energy you use in a wrong manner, the more noise will be made around it as well.
It's a very valid point.
Yes, it is.
That you always have to fulfill a certain noise level, independent of...
Yes.
So it's a very good point. So the data center is requiring usually very low noise level, which is also taking into account that people live close by. Usually the noise is not the issue, it's more the ugly building. The building is not nice to look at. I don't know. And that's, of course, then also a cost factor. So in Frankfurt, they only give you a permit if you have on the facade certain beautiful things. So that really fits into the picture. That's more the concern.
Thank you. Yeah. We're going to move to the next presentation. Many thanks. You're welcome.
And indeed, we had a quite interesting opening here on which we're going to come back on. Indeed, data centers do have an environmental footprint that is broader than just carbon and energy, and this is something that we're very interested to look into, where we're going to come back on this topic. Let me introduce the next speaker. He's a colleague from the European Commission, and I would say he's a veteran of the topic. Paolo Bertoldi has been working on energy efficiency of data center as a pioneer in the area, and is really the father of the European Code of Conduct of energy efficient data center. So, Paolo, it's really my pleasure to welcome you, even if you're remote today. That shows as well some of the benefit of digital technologies cutting on traveling costs. And so the floor is yours to introduce the work you've done on energy efficient data center. Thanks a lot.
Thank you, Pierre, for the introduction. I hope you can hear me okay in the room.
Yes, we can hear you perfectly. You're on screen.
Perfect. Thank you. Thank you. I think it goes a long way back. The first met you, Pierre, when I was dealing most probably with set-top boxes or broadband communication. Now it's a pleasure to work with you and your team on energy efficiency in data centers. I'm going to present to you the code of conduct that's been already mentioned by some of the previous speakers. So can you go to the next slide, please? So I'm working at the Joint Research Center in ISPRA. We are part of the Commission. We are more a scientific body, so we do technical scientific analysis and support the policy DG in Brussels with their policy. And with the code of conduct, we have been doing something that is a bit unusual for us because we not only collect data information, but we also try to push industry to do something to fill in a gap. Next slide. So data center, how much they consume was also a slide by the previous speaker, so I don't stay much on this slide. But just to say there are a lot of different assumptions, different numbers going around, but more or less they coincide. In Europe, we can say we're about 50 to 70 terawatt hours. It very much depends also what is a data center. Is the a building dedicated only to servers and network communication, or is a server room in a normal building where there may be 4 or 5 servers in a university, in an hospital. And then we also have more and more coming the edge data centers, so it will be even more complex to gather this. And this is only the consumption of the data centers. We should never forget then that the communication from and back to the data center, mainly through internet connections and via telecom services, is as much as the consumption in data centers. So while I'm talking to you now, I'm consuming for communicating to you, and most probably also to store everything that I say in a server somewhere. So the consumption is high and is predicted to increase. We don't know the wonderful of technology that might be will make a data center even more powerful at the same improving a lot dramatically efficiency. So we may have, yes, a larger increase in communication and data processing, as we heard from the previous speakers, but at the same time, we hope to have a very strong efficiency gains. Next slide. So the data center, sorry, it's not exactly, I try to synchronize with my presentation. Yes, it's this one. So we already heard from the previous speakers that data center consumption is big. There are big drivers in our at the horizon, which are good for society. 5G is coming. I just heard yesterday that there will be soon a presentation by Nokia of 6G, so a technology which is much faster than 5G, and so more encouraging for people to share data, video stream, teleconferencing, and things like this. Internet of Things, international artificial intelligence are all drivers from the previous speakers. So the sector is important in terms of contribution to the GDP, to contribution to the wellness of our citizens and our business, but it has an important impact on energy consumption. And we should also highlight that it has also a positive impact in sense of, like me today, not flying to Brussels, but this is even more complex to account. So we can say that about up to 2% of global electricity consumption goes into data centers. And it's important to keep in mind this number because sometimes I see figures like 10% of total energy, which is a bit too much. Is an important sector, but is not, let's say, the worst sector and should not be the bad sectors. And there is unfortunately a trend in some environmentalist groups, to blame a data center and not wanting any data center to be constructed because of the impact on the environment. I would say, is an important sector, is an important industrial sector, we say, in terms of comparison of emissions, but is not the worst. Next slide. So we started a long while ago in 2007, when there was no regulation, not much discussion. I'm very pleased now that all my colleagues in DG Energy, in DG Grow, in DG Connect are tackling the issue of energy efficiency in data centers, and also member state, member of the European Parliament are much aware. In 2007, it was just some interest in the industry, and we started to push for this issue, having done some research. And we decided to have a European initiative, not having different initiative in different member states, because also industry is very much European. There are players which have a data center in Sweden, in Italy, in France, in UK, serving the major hubs. So they wanted basically to have a common, if you want, rules or way to engage in European action that would be the same in the different member states. And not only this, but when we started, it was really to create a platform bringing together the industry, some policymakers, some academia, to discuss the energy efficiency data centers. So it was really the start of the discussion. And we're very pleased that the industry straight away, companies like IBM, like Digital Realty, like Interaction was mentioned before, joined the discussion. Also, the colleagues from Schneider Electric joined the discussion, help us to develop this data set, this code of conduct for data center. Next slide. So just a summary is, let's say, a voluntary initiative, which we, with pleasure, have led so far. Perhaps when it become, if will become a big initiative, we can pass it over to a policy DG in Brussels, which may be better equipped in relating with the business than us. Is a flexible mechanism, tries to say to fill a policy vacuum. As you know, there is from the colleague in DG Energy, there is a lot of regulation from the eco design on equipment, with the energy performance of the building directive on building itself, but the data center are a bit escaping both, because are a complex system with many pieces of equipment, which even if they are regulated and they're efficient per se, like a server, like a UPS, like a cooling system, is when you put them together and match the cooling with the load, with everything, that you really have the gain of efficiency. And we try always to look at the new technology and new solutions. And it was mentioned, for example, cooling. And now we look with strong interest to liquid cooling or immersion cooling as an alternative to cool the air or cool the whole data center hall, a big hall, just to have servers maybe running at 30 degrees. And we try also, of course, as any voluntary initiative, to have some criteria to participating, avoiding, greenwash. My data center is very green. I have a very efficient data center. Okay, if you claim this and you want to participate, you have to show us the numbers, the technology that you use, the solution you implemented. You have also to have a commitment at a very high level to look at the energy consumption and set up an action plan to reduce your energy consumption through energy efficiency and energy management. Next slide. So, as I said, basically this already covered. We have to remember always it's a voluntary commitment by individual company that operate a data center or owns a data center to reduce, I would say, to monitor and reduce energy consumption. If you don't monitor, you cannot really manage. And I'm very pleased to say that over the 10 years, through a lot of equipment supplied by companies like Schneider Electric, which serve this industry, that the monitoring is really widespread now. All the servers are record their energy consumption, the temperature, their performance. So there is a lot of data available to data center operator really to then manage properly the data center. Next slide. The code of conduct was very important to raise awareness among the managers, owners, and I say some companies were already aware, some were not really very much committed to energy efficiency, some enterprise data centers, some public sector data centers. And we also deal with metrics. And of course, when we started, there was not, it was just emerging POE. There was not a standard. I'm very pleased now the ISO and IC have come up with some standards that define not only PUE, but also other indicators like the renewable energy factor, the reuse energy factor, the camper factors. the water usage factors that are all important to understand how environmentally friendly is a data center. We still use PUE because for energy efficiency with some limitation is the best indicator. The next slide, please. An important point is that we cover this data center of all size, from small to big, because sometimes the small ones are the worst one, and the hyperscale data center are well designed and well run. We also work very much with the existing one, so the one that have been built 6, 7, 10 years ago that are going through refurbishment, that have also a lot of opportunity to improve efficiency. And of course, the new one. When you design a new one, should be high efficient, and most probably planning permission like around Amsterdam could be critical to say, okay, you have to have a PUE, design PUE down to 1 to 1.2, 1.3 when the data center is fully operational. We look at the IT part and the facility power, energy consumption, and we have two status basically, the participant, which are the data center owners, but we also very much have companies supporting us with promoting the code of conduct to their clients. So we use basically the industry to inform and make the other their client aware, and these are called endorsers. And for example, Schneider has been one of the endorsers since the early days because they have a lot of contact with the industry, they supply a lot of equipment, and when they say, okay, I propose to you this design or this UPS, they can also say, and this will help you to meet and participate in the code of conduct, and the client may say what it is, and they explain all on our behalf what it's about. Next slide. When we look at data center, it's a different industry from the steel making industry, where there is one plant and one single owner producing steel. Here we have a different type of operators. Sometimes a company owns the physical structure, but not a server, and somebody brings in their own servers. And this is a very typical model now as colo provider, colocation customer, or manager services. And so we try to say you all have a role in improving efficiency, and you can commit to improve the part you control. If you only control the IT, of course, you may request to be located in a data center which is efficient, but you cannot control the efficiency of the cooling system, of course. But there's still the role of procurement also in the private sector, how to procure a service, where you want to go, and what you ask from your colocation provider. As I say, it's very important to manage the energy, start with energy management, so tracking the IT consumption and the total site consumption, the temperature, and the indoor temperature, and then formulate an action plan to improve energy efficiency. Next slide. And sorry, next slide again. I was a bit faster. Try to save some time. This one, yes, perfect. I see on the screen now. And we help the company want to join the code of conduct with a document which is called best practices. And every year we discuss with the industry what are the best practices. We are the new one. For example, I was mentioning liquid or immersion cooling, new technologies, new way, also efficient software, efficient, of course, equipment, IT, non-IT, when can be deployed, is it for a new build or is it mainly for a retrofit? And there are over 100 of these best practices. And we work with, we say, at least 60 to 70 data center operators and technology providers. And every year we have a meeting and we release at the end of the year a new version of these best practices, which is a very well-known document in the industry. A lot of companies, even if they do not join the code of conduct for a number of reasons, they don't want to report to us, they don't want to make a public commitment, they still use this document. And we see from the download that we receive or the inquiry we get is even outside Europe is a well-received document. It's available for free on our website, of course. Next slide. So very quickly where we are. I don't know if we are successful or not. We have 380 data centers in Europe. About 250 have been really accepted and they submitted data to us from about 150 plus organization that owns, from the large one, Facebook, Google, IBM, Interaction, Equinix, to local data centers. Some are public authority, local public authority data centers. Some are university, hyperscale, high-performance computing, computers, research center. And we are more or less very present in Western Europe, a bit less in Eastern Europe, and the majority of our data centers are around the major data hubs. If you, yes, I have a picture later on. So next slide, please. So we cover a certain amount of consumption, not of course, which is about, I would say, between 5 and 10%. And we have some data on the typical data center that we cover. We see, of course, an increase in the data center, so a concentration and consolidation in the industry, which is good. One of the critical points that we monitor is the temperature set point. And it's very difficult to move this industry to higher temperature, also the ASHRAE climatic conditions are defined. Server can run at higher temperature. There is still a reluctance. There is still a belief in industry that everything should be around 22 degrees, and all the old data hall should be cool. So we try to drive the industry to, of course, to manage very well the cold and hot air flows, to have them optimized, to bring the cold air only where it's needed, not to cool everything. And also, of course, to increase this set point, making some calculation, of course, to avoid that then the server's funds runs too much, and to be within the warranties of the chipset manufacturers. But again, there a lot can be done to increase the temperature indoor, stay within safe limits, and reduce energy consumption. Next slide. So, of course, country up in the north of Europe can use a lot of fresh air. They don't have a very hot climate, especially if you look at Finland, Norway, Sweden, and they tend to perform a bit better than the one in Southern Europe. This is not a big surprise. So it's difficult to say in Europe every data center must meet a certain level of PUE. I think we should also look at the location is in a city center of a city where is already the air gets very hot because of a lot of buildings, a lot of activity, or is in a nice countryside up in northern Sweden. And I just throw in a kind of a bit of points that could be taken up in your discussion later on, or just for your information. Next slide. This is the slide I wanted to show before. As expected, all majority data centers are around the big hubs: London, Paris, Amsterdam, Frankfurt. Now also in the southern Europe, Milan, Marseille, and Madrid are also emerging, fostering communication towards Northern Africa and Africa. When we look at the participant, we have still a large number of traditional enterprise, but it's diminishing. Then we have hosting, internet company, performance computing, and the telecom are still an important player in this market. And they, of course, have a lot of expertise also on the communication side. Next slide. Sorry, I didn't say. So this was the previous slide. So we can go to the next slide. Sorry, I didn't ask you to click. Just a distribution of PUE. Be reminded we have a lot of old data centers in the code of conduct. I think 1.6 to 1.4 is anything in this range could be considered already good. Of course, we have also the 1.0, 1.2, which are the extremely good, which are the new design, which are usually companies do know a lot about how to design and run in data centers. Of course, in this category, we have one from Google, one from Facebook, but also other. But it should be the target, as was said before, for all the new design, with a lot of attention to the design and to the management of data center. Next slide. So I hope it was not too long. So Some very quick conclusion, and then I'm happy to take your questions. So we have seen from our data that through this action, we see a decline in POE year after year, and it's a good sign, especially in old one. We have reached an average of 1.8, and we want to bring this down to 1.6, 1.4 with a lot of small and existing data centers. Some well-designed data centers are below 1.2, and it's good. I mean, these are really good numbers. We don't need to be 1.001. Yes, this would be fantastic, but sometimes even questionable if it's so low. And as you can imagine, the data center located in Scandinavia, North Scotland, have very good climatic condition. Of course, they're a bit far away from major hubs. There is still a lot of demand for data center in major cities where the banking, the financial world, the telecom are located, and this is still will be the case. And we see that also sometimes very large, but also very small data center perform better. We see that the traditional enterprise size of medium-sized data center very often are the worst one, and many of them most probably will be dismissed to join the cloud, to join colocation, and having gain in scale and efficiency. Thank you for your attention. You have here my contacts if you want to reach out to me for further question or information on the code of conduct, or you can visit our website. Thank you again.
Okay, thanks a lot, Paolo, for the very comprehensive presentation, and it's very good to have a long-term perspective on this sort of self-regulatory practice and the impact it actually has on the long term. And we're very happy to see that quite a number of market operators have mobilized themselves on adhering to this European Code of Conduct. What I propose is that we move already to the next presentation, because we're running short of time, and we're going to take the question at the end of the two presentation. So let me welcome our next speaker, Vlad Coroamă. My apologies if I mispronounce. Vlad is a lecturer at ETH Zurich, and he has been working extensively on assessing the environmental impact of internet infrastructure, and notably the streaming aspect on the internet. So we're looking forward to hearing from the study that you have made in this area. Many thanks.
Thank you, Pierre, and thank you for having me here. I'm the last speaker, and I have lots of numbers, so let's see how this plays out. And I only address energy and carbon, but we can then talk about other types of impact. The main question I want to address today is, as we went from traditional TV broadcast to a world like here, where we stream from data centers, individual streams to each user, did video streaming reach a point where its impacts are comparable to those of offline? Or to put it in other words, is digitalization in general, and video streaming in particular, one of the main drivers behind anthropogenic climate change? And this, of course, as we all know, we need to move fast. We need to start now to have any chance to reach a 1.5 or 2 degrees warming only. We need to start now and halve our emissions every decade, so follow a path like this, right? And in this general context, the research that I am doing in the domain of ICT and sustainability has two main questions that Pierre also mentioned in the beginning. One is, how much of this is digital technologies? How much is digital part of the problem? And can it be also a part of the solution? Can it be a good lever to force emissions down in other sectors across societies and across economies? And streaming, my main topic today, so I only address, by the way, the first question, right? The footprint of digitization, and in particular streaming, which had a bad press lately. We had it in newspapers from the UK, from the US, or from Switzerland, but many more, Germany, France, that streaming is the new flying, is contributing essentially to climate change. And most of these projects rely on, most of these reports rely on a recent study that was published by a French think tank called the Shift Project, that was published first in November last year in French, translated this March into English, and that painted quite a bleak picture of the footprint of digitization in general, but streaming in particular today, and especially how it will develop by 2025. This study itself relies mainly on a paper published in 2015 by two researchers from Huawei Research Sweden, and building on top of this, the French study comes to the conclusion that streaming needs almost 0.5 kilowatt-hours per gigabyte in the networks only today in 2019. And of course, multiplying this with the zillions of gigabytes that are sent every year, this leads to quite a large number, and hence it would be the new streaming. But if we look back at the original data source, the Huawei study, this is quite a pessimistic. It's by far the most pessimistic that exists out there. The range, as we have seen also in Paolo's presentation, the range is quite wide, and this is by far the most pessimistic. It predicts in the worst case scenario that we would reach 30,000 terawatt hours per year for all digital technologies. This is the worst case scenario. There is also a expected one and the best one, but the worst one is this. So 30,000 in the context where today we have 25,000 worldwide. So the electricity consumption worldwide, 2017 is 25. So it would be more than a doubling, not of digital technologies, but of all the electricity worldwide just for digital technologies. So quite pessimistic. This, by the way, it's the 25,000. And it has been amended by the main author of that study himself, because from 2015, when it was published, to 2019, there was barely an increase, at least in the data centers, it was quite flat. So those numbers have anyway been updated by the main author. But taking a step back from this, which is sort of the motivation, the current media hype around streaming, let's see what science has to say. And science basically has two ways of addressing this question. One I call the macro view, and the other one is the micro view. In the macro view, we have top-down assessments of the total consumption, so now the number starts, sorry for you, of the total consumption of networks worldwide. And how this is done, typically, the authors take a couple of telecom companies from which they know both the energy consumption and the number of customers, and extrapolate this to all of the traffic worldwide, all of the customers, ideally, but also by also weighting in fixed network versus mobile networks that have different footprints. The micro view has a very different methodology. What it does is it assesses not the entire energy, but what is called the energy intensity of the internet. So how much energy do you need to send a certain amount of data across the internet? This is sometimes measured in joules per bit, but because both of those units are ridiculously small, usually it's kilowatt hours per gigabyte. And how this is typically done, you take a case study of one connection where you know all the consumption and the traffic, and can, by dividing the first by the second, you get the energy intensity. Or you take a company, BBC, such an example that colleagues from Bristol, Chris Priest and Daniel Sheen have done. They looked at BBC. BBC knows very well how much data it sends to the customers, the energy consumption along the way, so you get the energy intensity. And now connecting these two, the macro and the micro view, is the worldwide traffic. Because ideally, when you look at a macro view, and you would divide this by the worldwide traffic, you would get the energy intensity that you should ideally have also coming from the bottom up, right, and having a case study. Or the other way around, if you take the bottom up view and multiply this, so you have the intensity and you multiply this by the traffic, you land at a worldwide energy. So let's look at this for a couple of minutes. The macro view first. This is a study by the lab of Mario Picavet here at Ghent University that Paolo also cited before. It's a very well-known study that looked at all digital technologies. We're only interested in networks, telecom operator, office networks, and customer premises equipment, CPE, that I will address a couple of times today. And they looked from 2007 to 2012. In 2012, they were by 330 terawatt hours per year for all the networks worldwide in their top-down study. And this was growing by 10.5% per year. So if we were to extrapolate these numbers, would reach today 670 terawatt hours per year from the, I remind you, 25,000 worldwide electricity annually. A more recent macro view is from Ericsson and TeliaSonera that looked at over 100 telecom companies from China, from the US. These are the numbers starting from the most important of them in terms of energy consumption, and they represent 2/3 of the customers worldwide. And this yields 164 terawatts, and extrapolating this to 100%, as any top study does, one would come to 250 terawatt hours per year, so a factor of 2.5 lower than extrapolating the older numbers to today. So already between top-down studies, you see here quite a spread. And if we take the Huawei study, that's above 1,000 terawatt hours, so the spread is even larger, and that's also a top-down study. If we look now, let's take for a second the other approach, the micro view. So we start from case studies. I did such a case study. I worked with colleagues at a case study 10 years ago. We had a conference that we organized simultaneously in Davos, Switzerland, and in Nagoya, Japan. And we connected the two venues by 4 high-definition video streams. And we not only sent the speaker, the image of the speaker, together with the slides, but we also projected the audience from the remote site locally to create a sense of togetherness. So imagine you would have here the other audience, and I would address like this both audiences, right? This was the concept that we have done back then, and we also allowed natural interactions, including cross-continental Q&A sessions. There were also informal interactions during coffee breaks, where of course there was a 7 hours difference. There is a 7 hours difference between Japan and Switzerland. They are ahead of us in Europe. So the common sessions were 3 to 7 p.m. in Japan, 8 a.m. to noon in Switzerland. So at the end of the day, of their day, it was our lunch, and we found out that there is no sushi over IP, unfortunately, nor beer. They were having beers. We had still coffees. So if you ever want to replicate this, I would advise you do it with a continent on the west. So they get to wake up early and you get to have the beers. But we used this case study to make such a bottom-up assessment of the energy intensity of that video stream, because we needed to guarantee a delay for this natural interaction. 150 milliseconds is the maximum delay you can have to still have a natural interaction. We couldn't use the shorter eastwards route as seen from Switzerland, because there we could not guarantee the delay. So we had to go over the Atlantic, over continental US, over all of the Pacific into Japan. But we had very good control. We knew exactly the energy consumption and the traffic of each node and each fiber along the way. So we could do this bottom-up study. And that's how it looks like. Over the 3 days, 4 hours per day, we sent 108 gigabytes across the networks, and for the 20 megabits per second. And the entire, so allocating from all those things with a conservative PUE of 2.0, by the way, allocating to our conference traffic, we had 20 kilowatt hours across worldwide networks, so 0.2 kilowatt hours per gigabyte. So this is just one example. Again, many other examples exist. Kerry Hinton in Australia did some, Picavet and colleagues here in Belgium, Priest and Sheen in the UK, Lawrence Hilty in Switzerland, John Coomey in the US. So there's many such bottom-up assessments. And this is a plot from Coomey and colleagues. It's a logarithmic plot showing these estimates along the time. So the best known academic estimates along time. And of course, there is a regression due to efficiency wins. So the efficiency gains lead to this decrease. And as you might see, very neatly, this curve hits 2019 at 0.01 kilowatt hours per gigabyte. So 10 watt hours per gigabyte, which is a factor 43 less than the Shift project study that I mentioned in the beginning. Those were 430 watt-hours per gigabyte. Now we have 10. So quite a spread there. Coming to the link between the two, macro worldwide traffic, that's simple. We basically grow a factor of 1,000 every 10 years, from terabytes in the 80s to petabytes in the 90s, exabytes in the 2000s, and now zettabytes, right? And the best data source for this is Cisco's Virtual Networking Index. They're the best company because they have so many routers to compute such data. And for 2019, we are at 200 exabytes per month, which means 2.4 zettabytes per year. Zeta is 10 to the power of 12 giga because we have tera, peta, exa, zeta. Okay? And now if we take some bottom-up estimates, so the 10 watt-hours that we had before, this would lead to 10 terawatt-hours per zettabyte. So for the entire world traffic, 24 terawatt-hours. An order of magnitude below the top-down estimates, 650, 250. So we have a problem. I have some other study that I didn't talk about that would lead double 50 terawatt-hours plus a separate accounting of CPE. So there are here in bottom-up studies, there is also a discrepancy, but mainly we are one order of magnitude between top-down studies. So we have three incompatible estimates. We have the energy from top-down studies of worldwide networks, hundreds of terawatt-hours per year. Bottom-up studies that tell us somewhere 10 to 20 watt-hours per gigabyte, and the worldwide traffic. And if we multiply 2 by 3, we should be at 1. Or if we divide 1 by 3, we should be at 2, but we're not. We are one order of magnitude apart. So where does this discrepancy come from? I took Swisscom as an example because Swisscom has a very good sustainability report, very detailed one, and Switzerland has the nice characteristic of being roughly 1/1000th of the world, and Swisscom dominates there the market. So taking Swiss numbers and multiplying by thousands would be a very sort of simplistic top-down estimate by taking just one company and extrapolating it to the world. And it would lead actually to quite a good number that is there with the top-down assessments, 500 terawatt-hours per year. But if you look more closely into their sustainability report, then you see that 20% of that number is the fuel to heat the buildings and the fuel consumption of Swisscom's fleet that are not digitization. In a life cycle assessment, they would probably, but we don't go into this, it's not, they are accounted for in other sectors, in a mobility sector, in building sector, right? And of what remains as electricity, a large part, I don't know which part, is data centers. Only the savings in data centers are 20 gigawatt hours per year due to new technologies they deployed. You might ask, why does a telecom operator need data centers? Well, for its TV offerings, for collocating third-party data centers in a sort of edge computing, having them close from content providers such as Netflix or CDNs, and especially in the case of Swisscom, cloud storage for both private persons and businesses, an important business model of Swisscom. And all these things, of course, are already accounted for in data centers. So if we put this into networks, not only do we arrive to a wrong number for networks, but we also do double counting. Which leads me to typical flaws of top-down assessments. They can easily count things that should not be counted for because they don't belong there. Or in environmental terms, the system boundaries are too wide, leading to double counting and thus to overstatements. Bottom-up assessments also have their flaws, of course. They often, so for example here, many of the bottom-up assessments focus on fixed networks only, not on mobile ones, although not all of them. Many forget customer premises equipment, although not all. And what most of them forget is legacy equipment, old copper cables, 2G, 3G that is still there, redundancy equipment, and so on. So what they do, they easily forget things that should not be forgotten. They have too narrow system boundaries and lead to understatements. So again, comparing the two, one count too much, the other too few, and ones lead to overstatements, the other one to understatements. So the truth is probably somewhere in between. And to approach this truth, if we are to add things forgotten, typically forgotten to bottom-up estimates, or take out some things from top-down estimates that shouldn't be there, we arrive in a range of very back-of-the-envelope-ish 200 to 500 terawatt-hours per year for the networks. 75% of which is streaming. Streaming is dominating internet data flows as it's growing. It's projected by 2022 to be 82%. So that's 150 to 375 terawatt-hours per year, which is 0.6 to 1.5% of worldwide electricity. And because electricity is a sixth of worldwide energy, that's 0.1 to 0.25% of worldwide energy. And if we take the worldwide average carbon intensity of electricity, which is very conservative for digitization, they all often deploy renewables actually, but let's take this, we're at 200 to 230 megatons per year, which is 0.2 to 0.5% of worldwide greenhouse gases, so CO2 equivalents, not only CO2, of course. And for streaming, of course, you also need a part of the servers that I didn't talk about. I only talked about networks. From data centers, it's much less. I don't have time to go into detail why. But if we account for those as well, we add another 0.1 to 0.2% of greenhouse gases. So for streaming alone, we clearly stay below 1% of worldwide energy and greenhouse gases to the best estimates that we can say today. And I took the macro and the micro view. In the last minute, I want to take what I call a nano view. Because these recent press releases made some people, and I heard it in my environment, people telling me, okay, so I didn't stream so I can fly, because streaming is the same as flying. So taking the nano view, taking one instance of streaming versus flying, there is no question. Here I took a slide from Lawrence Hilty from the University of Zurich. If we take again the 10-year-old Davos Nagoya case study, irrespective of the number we take for streaming, whether our number for back then, more modern numbers that are one order of magnitude lower, or the very pessimistic shift study numbers, which is the last row, and add all the local equipment as well, we saved by the connection, by providing to venues, we saved 70 to 80 intercontinental flights. And all the energy consumption and the corresponding CO2 would be less than 0.1 intercontinental flights. So on this nano view, it's always better, as we transported Paolo's image via bits, it would have been much better than as we transported my atoms, which is quite a few of them, I have to admit. So it would have been much better to also transport my bits. So we need to act swiftly, as we know. I didn't talk about digitization overall, but it's about 6%. From Paolo, we heard 7% of worldwide electricity, which corresponds roughly to 1% of worldwide energy and greenhouse gases, compared to 3% flying, and this is not accounting for the vapor, for the potential, the warming effect of the vapor, so this is only the CO2. And streaming is an important, but just a part of it. And the last point I want to make is that internet access is much more democratically distributed around the world. Many people around the world take advantage of it to entertain themselves, to educate themselves, to participate in worldwide economy, in the worldwide discourse. And flying is reserved for relatively few. And especially, there is no moral licensing. If you didn't stream last month, you're not allowed to fly to Bangkok and have a Thai curry there, right? So my last slide is, we have to move fast. We don't have much time left, and there is no time to chase the wrong culprits. And streaming is probably not one of them. Thank you.
Question. We have only 5 minutes, so if there are still one or two questions that have not been answered, many thanks, Vlad.
Thank you.
Stay on stage. Stay on stage. If everybody wants to ask a question, that's quite provocative. That what you have been, but it's evidence-based, so it's I think it's quite a wake-up call on identifying the right determinant of energy consumption and carbon emission, but also other pollutants stemming from the ICT sector. It shows as well the big importance of methodologies. From your experience, if there are no more questions, how do you see we could systemize the approach to measuring the environmental footprint of ICT?
I think it's very...
Based on all your various experiences.
I don't know. I would actually let Paolo answer first if there is a question, an answer from there. I'm not sure he hears us, so my answer would be it's because the internet is so heterogeneous. It's so many technologies. We have to work with so much averages and assumptions and so on. So it's a very, very tough question. So what we can do is to try to understand, to publish, if possible, in peer-reviewed things so that others can correct, although this is a slow process. And to agree where we agree and where we disagree. At data centers, we agree, fairly good. For end-user devices, it's already more difficult. For networks, it's probably the most difficult task to assess. And this can be seen in the wide range of assessments that are out there.
I have a question myself. May I ask you a question? My question is whether in your forecast or the other scholar that you cited, the new trends have been included, like, for example, blockchain, autonomous vehicles, Internet of Things. So a lot of communication will be between devices, not anymore human with a machine. So, and this seems to require a lot of additional energy. Nobody has yet quantified the impact of blockchains or Internet of Things or autonomous vehicles or artificial intelligence.
I totally agree with that. And predictions are difficult, particularly about the future, as we know. And when we go to this prediction, I think, so a short answer would be there will be some economic constraints. If the world electricity were to double because of digitization, I could not have my 10 gigabit per second flat rate anymore for 40 francs per month. It would require much more. Either it would be much more expensive or it wouldn't be a flat rate anymore. So there will be some economic constraints that the extremely pessimistic studies tend to ignore, but I'm no economist, so I cannot answer that. I think there will be, of course, especially machine learning training, there will be lots of consumption on server side, as you say, autonomous vehicles and so on. I think what often, but I do not expect, even by 2030, digitization to have a huge impact by itself, but I think it could induce very large rebound effects that most people ignore today. So the indirect effect of digitization, both the positive but also the negative ones, and autonomous vehicles is a very good point. If I can now I take the train from Zurich to Bern when I go for a meeting, right? For two reasons, because I want to work in the train, and second, I find no parking slot. But if I can take my autonomous vehicle, work in it, and send it back to Zurich or have it go around the block for 2 hours in Bern, I might be tempted to do this because I don't expose myself to viruses in the train and I don't know what, to loud kids, and I can focus better. So this indirect effect of digitization that will not be the footprint of digital itself, but in other sectors. This is what my research now focuses most about.
Maybe a word to complement on our side, the algorithmics is very important for software. We've seen this in the case of blockchain. Poor algorithmics can lead to environmental disaster in the way blockchain is practically implemented, but good algorithmics can actually lead to enormous energy efficiency. So educating coders, educating developers is extremely important to teach them how to write good code that will not consume a huge amount of energy down the line. We're going to take the last question here.
Quickly
and,
back
we're
to
going to wrap up. Philippe, please.
Quickly back to the video streaming. Do you have any idea what we could do still in this area to reduce the footprint? What is the single most efficient thing we could do? For example, is it caching, more generalized caching when it's possible, or multicasting instead of uni-stream? What is the single most efficient thing to do?
I will cite Chris Priest, a researcher from Bristol University, who says there is two main things we can do today. One is to eliminate set-top boxes, which are still a very large. They have checked satellite versus cable versus streaming, and a very large portion is there. And what he claims, and I agree to that, is that motivating consumers to do something is very difficult, and it has a very low impact. So it has always to be on the content producer side, and have there the instruments, and we've heard this today, perhaps with the European Code of Conduct, to reduce both on data server, but also on the sort of amount of data sent across the internet. So there is the lever at producers, not at consumers.
Interesting. And thank you for the very rich presentation.
Thanks a lot, Philippe. I'm just making a check if there is any further question from the Luxembourg colleague before we wrap up. Luxembourg, I don't see.
No, thank you. No questions from here.
Okay, many thanks. So let me thank you for your attention today. I think we have seen through the variety of presentation the enormous challenge that is at hand, starting with measurement. I think this is really an enormous challenge for us as policy makers. I know the colleague in DG Grow, DG Environment have been working extensively on trying to harmonize solid methodologies that measure not only the energy footprint, but more broadly other environmental aspect, water, material, and this is something that we will need to look into in due course. So measurement methodologies is absolutely essential. We've seen metrics is also something very important, especially for a data center. What are the right metrics that we need to look into if we want to push the sector, the cloud sector, the data center operator in becoming more energy efficient? But beyond trying to increase the energy efficiency of data center, of course, the electricity consumption of data center is just the symptom of a broader problem, which is the explosion of data. So we also maybe need to look at other policies on data. So do we need to keep data forever stored on server? Do we need to look at other data policies like data retention, data archiving that could also help eliminate some of the problem at the source? So that's also part of the policy mix that we have to consider and continue discussing in due course. The presentation material will be made available on Connected. This video has been recorded and will be made available on the Futurium website of the European Commission. Let me thank all the 4 speakers of today, Paolo from ISPRA and the 3 speakers that came here in Brussels today. Many thanks for your commitment and coming to present the fruit of your research and your work. We're very grateful. That stimulates a lot the policy debate. My personal thanks to my colleague Liv Westreim, who has been the organizer of this session and who has facilitated this session today together with our colleague from the Connect University. So many thanks to all of you, and wishing you all a great day and looking forward pursuing the work with you. Join me in a round of applause for the speakers and